Hello everyone and welcome to our next lesson. Today is April 28th, 2020. And today we're going to be talking about section 5.2, right triangle trigonometry. Okay, so let me just introduce this by drawing a right triangle. So we've got our right triangle here. There's some sides that, first off, the hypotenuse, we'll label this side C. C is the hypotenuse, otherwise the side across from the right angle, or it's also the longest side. Okay, we're going to label this angle here theta, and then we're going to call this, we'll call this corner A, and then B and C. So these are the, A, B, and C are these points, not the sides. But so this is capital C, and this is little c. So this, the side opposite of A would be little a, and this side opposite of B would be little b. Okay, so we're going to introduce some of the trig value, or what these, the definitions of sine, cosine, tangent, and the other three, cosecant, secant, and cotangent. Okay, so the sine of theta, remember, so sine is a function, so you have to put an input into it. So sine of theta is equal to the opposite over the hypotenuse, which in our triangle is going to be little a over c, since the opposite side of this angle is a, and then the hypotenuse is c. Excuse me. Cosine of theta is equal to adjacent over the hypotenuse. Okay, so that's going to be b over c. Okay, and then tangent is equal to opposite over adjacent, which is a over b. Okay, also you have some other, let me refill my pencil with some lead here. Okay, got that, some more lead in the pencil. So now we can define also the cosecant of theta is equal to it's the reciprocal of sine, so it's the hypotenuse over the opposite, or c over a. The secant of theta is the reciprocal of cosine, so that's going to be the hypotenuse over the adjacent, which would be c over b. And then the cotangent of theta is going to be the reciprocal of the tangent, so it's adjacent over the opposite. Whoops. Opposite, not opposite. Okay, so that's going to be B over A. All right, so that's how that's defined. So, for example, if we had the following triangle, let's say we had a triangle that was so we have 3, 5, and 4. So this is a right triangle. You could check. And if we wanted this angle, if we called this angle here theta, then, for example, sine of theta is the opposite, so 3 over 5. The cosine of theta is the adjacent over the hypotenuse, so 4 over 5. And the tangent of theta is going to be the opposite over adjacent, so it would be 3/4. Okay. So we have to be careful when we're writing these because when we're writing these expressions, because it would be incorrect to write, for example, sine equals 3/5, because we don't know what we're taking the sine of here. Sine is a function. It's not a it's not a value. It's a function. So you need to have an input. Sine theta equals 3/5. Right, and so you can kind of think of this as, we were doing f of x, where f was a function name, while sine of theta, theta is the variable and sine is the function name. Okay, so if we move on here, let's do an example. Let's say we have this triangle here. Oh, there's one other thing we need to know. The Pythagorean theorem. Okay, so for a right triangle, a squared plus b squared is equal to c squared. Okay, so let's do an example here. So we've got the following triangle. Okay, so we have theta, little c is unknown, this side is 3, and this side is the square root of 7. And we know that this is a right angle. It wants us to find, the instructions are find the 6 trig find the values for the 6 trig functions of the angle theta. Okay, so right off the bat, there's two things that we know. We know the opposite and the adjacent, so we can find that tangent of theta right away without doing any work here is 3 over the square root of 7. And the cotangent of theta is the square root of 7 over 3. Again, because the tangent is the opposite over the adjacent, and the cotangent is adjacent over opposite. So if theta's here, the side opposite is 3, and the side adjacent is square root of 7. The adjacent side is not c, because remember, c is the hypotenuse, as it is opposite of the right angle. Okay, so how are we supposed to find the other 4 if we don't know what c is? Well, that's where we can use the Pythagorean theorem to find out what c is. So a squared and b squared are just sides of the triangle, so we'll find it. So c squared is equal to the square root of 7 squared plus the square root, I'm sorry, not the square root, plus 3 squared. So that's equal to 7 plus 9, which is equal to 16. So c squared is equal to 16. Well, that means that c is equal to 4. And some of you might be thinking, why didn't he do plus or minus 4? Well, I'm eliminating the negative 4 because you can't have a length of a negative length. Okay, so c equals 4. Nice. Okay. So now we're going to have to, now we can use that to find the following values of the 4 other trig functions at angle theta. So if I want to do the sine, it's opposite over hypotenuse, so it's 3/4. If I want to do the cosine of theta, it's adjacent over hypotenuse, so square root of 7 over 4. If I want to do the cosecant, that, oops, see, I made the mistake right there. I almost write cosecant of nothing equals, I need the cosecant of theta. So that's the reciprocal of sine, so it's going to be 4 over 3. And finally, the secant of theta is the reciprocal of cosine, so it's 4 over the square root of 7. Okay. Right. So that's how you would find the 6 trigonometric values. So sometimes you have to solve for that unknown there, using the Pythagorean theorem. Okay, moving on. So like I was saying before, cosines, or cosecant, secant, and cotangent are reciprocals of the sine, cosine, and tangent, respectively. So we can keep this in mind. Cosecant of theta is equal to 1 over the sine of theta. Secant of theta is equal to 1 over the cosine of theta. And cotangent of theta is equal to 1 over the tangent theta. Okay. So there's also some other things we can talk about here. So if we have these, we also can, you can write, for example, if I take this top one here, cosecant of theta is 1 over the sine of theta, I could write, if I multiply both sides by sine theta, I get sine theta times cosecant of theta is equal to 1. And same with this one. If I multiply both sides by cosine, I get secant theta cosine theta is equal to 1. And here, similarly, we get cotangent of theta times tangent of theta is 1. And you also can notice that from, again, if I start at this with cosecant of theta equals 1 over sine theta, if I multiply, or this one, now if I divide both sides by cosecant, then I get sine theta is 1 over cosecant of theta. So then cosine theta is 1 over the secant of theta. Right, they're reciprocals of each other, so it should come as no surprise. And tangent of theta is 1 over cotangent of theta. Okay, so we have all those relationships to work for. So using these, let's use these on an example here. So if sine of theta is equal to 5 over 13, and the cosine of theta is equal to 12 over 13, find, find tan of theta, cotangent of theta, secant of theta, and cosecant of theta. So there's one also other thing we have to remember. So or we have to know, so tangent of theta is equal to the sine of theta over the cosine of theta, and cotangent of theta is equal to cosine of theta over sine of theta. So this one here, tangent of theta is equal to sine over cosine. So remember, tangent, before I start talking about this example more, tangent of theta was opposite over adjacent, right? So maybe if I write on a different, if I can write, I'll move my camera down here, right, for this explanation. So the tangent of theta is equal to opposite over adjacent. Okay, so remember, sine of theta was opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. Right, so think about it. If I do sine divided by cosine, I'm getting the opposite over hypotenuse, a fraction, divided by the adjacent over the hypotenuse. So what do we do when we multiply, or when we divide fractions? We multiply by the reciprocal. So if you multiply by the reciprocal, you'd have opposite over adjacent times, opposite over hypotenuse times hypotenuse over adjacent. So the hypotenuses would cancel out, and you're left with opposite over adjacent. So then, if that's how tangent of theta is equal to sine over cosine of theta, and if cotangent's just the reciprocal, then it's cosine over sine. Okay, so now back to the example. So, first, if we, for example, if we wanted to find the tangent of theta, we'll just follow the list here. So we can use this, since we know the sine and cosine of theta, we can use that to find, we can use this relationship here to find tangent of theta. So tangent of theta is equal to the sine of theta over cosine of theta, so 5 over 13 over 12 over 13. So what do we do if we multiply, or if we're dividing fractions? That's the same thing as multiplying by their reciprocal. So that's equal to 5 over 12. Okay, so now that we know sine, cosine, and tangent, we can just use all the reciprocal identities. Cosecant is equal to 1 over sine, secant is equal to 1 over cosine, and cotangent is equal to 1 over tangent. So if I want to find cotangent, it's just 1 divided by 5 over 12, which is equal to 1 times 12 over 5, which is 12 over 5. Similarly, secant of theta is 1 over cosine, so it's 1 over 12 over 13, which is equal to 1 times 13 over 12, so it's 13 over 12. And similarly, the cosecant of theta is the reciprocal of sine, so it's equal to 13 over 5. Okay, so that's how we can use those relationships, reciprocal relationships, to find, if you're given certain values of, if you're given 2 values, you can find the rest of them. Okay. Okay, so now another example. So find the other 5 Okay, so the question, or the problem is find the other 5 values of theta, given that theta is an angle of a right triangle with sine theta equal to 2 over 5. So they really, in the last example, they gave you 2 of them, and now they only give you 1, and they expect you to find all other 5 of them. Okay, so we got to think about, we got to remember, what does sine theta equal 2/5 mean? Well, sine theta, remember that was opposite over hypotenuse. So, you know, we can draw a little sketch of a triangle here, and it might not be right, but we know that the hypotenuse is 5 units long, and the opposite, the angle opposite, if I just put the theta down in this corner, is 2, right? So opposite is 2, and hypotenuse is 5, opposite hypotenuse. And so that's a rough sketch of what the triangle we're working with here. Okay, so there's a couple things we can use here. Well, we can already, if we know the sine of theta is 2/5, well then we can use the reciprocal identity, and we already know what the cosecant of theta is. It's just 5 over 2. But how are we supposed to find cosine and secant if we don't know what this side is, right? For cosine, we need to know the adjacent side. So we can use Pythagorean's theorem again to find that. So this time we have, remember it's a squared plus b squared equals c squared, where c is always a hypotenuse. So it's 5 squared is equal to, let's call this unknown value x. X squared plus 2 squared. So that says that should draw an arrow. 25 equals x squared plus 4. So if we subtract 4 from both sides, we get that 21 is equal to x squared. Or x is equal to the square root of 21. Okay. So now we have information on all 3 sides. So now we can use that the cosine of theta is the adjacent square root of 21 over the hypotenuse. So the square root of 21 over 5. Okay. So then that, by the reciprocal, we get that secant of theta is 5 over the square root of 21. And just in case your homework asks you to do this, we may have to rationalize a denominator. So if I multiply both the top and bottom, the numerator and the denominator, by square root of 21, this is equal to 5 times the square root of 21 over 21. But this is good enough for me. But, I mean, the company writes the homework problems, and I just choose ones that go on there. So this might be the answer that the homework wants. Okay, so then tangent of theta is opposite over adjacent. So 2 over the square root of 21, and by the same process here, this is equal to 2 root 21 over 21. Okay, and then cotangent of theta would just be the square root of 21 over 2, since it's the reciprocal. Okay, so just given this one piece of information, that sine theta is equal to 2 over 5, we actually figured out the third side of the triangle, and we figured out all of the other all 5 other trig values of this angle. Okay, so now I'd like to talk about some special triangles. Okay, the special triangles include angles, or right triangles with angles 30 degrees, which I'll give you it in radians too. This is pi over 6 radians. Here, I'll write it at the end, or under. Okay, 45 degrees and 60 degrees. So this is going to be pi over 6 radians. This one's pi over 4 radians. This one's pi over 3 radians. Okay, so so for example, if we want to talk about a right angle with 45 degrees, well, we also, if you don't remember this from geometry, it's okay. But if you have a triangle, it doesn't have to be a right triangle necessarily, but in any triangle, the sum of all three angles must add up to 180. So if you have 90 here and one of them is 45 degrees, well, 90 plus 45 is 135. So then the other angle has to be 45 degrees as well. So this is what we call an isosceles right triangle. So it turns out isosceles means that these two sides have to be the same. So for example, for this example, we're just going to set them both equal to 1. Okay, and then by using the Pythagorean theorem, we could solve that. So c squared is equal to 1 squared plus 1 squared. So c squared is equal to 2. So c is equal to the square root of 2. All right. So now let's use this to figure out what sine of 45 degrees, which is equal to the sine of pi over 4 radians. So if you're in your calculator, you have to make sure you specify whether you're using degrees or radians. So if we use this, the sine, if we're talking about this angle here, the sine of 45 degrees is the opposite over the square root of 2. So it's equal to 1 over the square root of 2. And if you rationalize, this is the square root of 2 over 2. Okay, cosine of 45 degrees, which is the cosine, again, of pi over 4 radians. So here I'll put radians, degrees, is equal to, so this one, looking at our picture, it's the adjacent over the hypotenuse. So it's 1 over the square root of 2. So again, square root of 2 over 2. What about the tangent? So the tangent is the tangent of 45 degrees is sine over cosine. So square root of 2 over square root of 2, same number over the same number, so it's 1. Or we can think of it as opposite over adjacent, 1 over 1. Okay. You can use these to figure out what the cosecant, secant, and cotangent are. Okay, so now consider this. Those are the special angles for 45 degrees. So we still have to talk about the 30 degrees and the 60 degrees. So for a second, I'd like you to consider this triangle. This is called an equilateral triangle, and that means that all sides have the same length. So we're just going to make them all length 2. Okay, let me make a quick comment here. So back to this triangle here. Any right triangle, so if you have a right triangle and two 45-degree angles, that means that it has to be an isosceles triangle. So these two sides don't necessarily have to be 1, they just have to be the same number. But even if they are the same number, then you're, so for example, if they were both 5, so you'd have 5 squared plus 5 squared, so the square root of 50 on this side. These ratios will always reduce to these 3 values, no matter, you just have to have these angles. It doesn't necessarily these side values based on their angles are always going to have the same sine, cosine, and tangent ratios if you have those angles. And that's the same to say with the 30 degrees and the 60 degrees. Okay, so now to introduce the 30 degrees and the 60 degrees, I'm going to think about a equilateral triangle. So first off, an equilateral triangle is not a right triangle. All three of these angles, an equilateral triangle means that all sides are the same, and in fact, if all sides of a triangle are the same, all of the angles have to be the same. And you can picture that because if, let's say one of these angles is a little bit bigger or smaller, well then that would shrink the size of that side across from it, and it would no longer be the same as the other two. Okay, so now let's redraw this picture, except I'm going to split it into two. So, and this is going to make two right triangles here and here. So if I'm splitting this in half, this side becomes a 1 and this side becomes a 1. And now I've split this angle in half, so this angle is now 30 degrees. This one's still 60 degrees, and this side is still 2. We need to figure out what this side is. So we can use the Pythagorean theorem. So the 2 is the hypotenuse, so 2 squared is equal to 1 squared plus our unknown squared, so I'll just put x squared. So then that's 4 is equal to 1 plus x squared. So x squared is equal to 3, or x is equal to the square root of 3. Okay, so now we have our full picture, if I can redraw it. So this side is the square root of 3, has length square root of 3. This side has length 1, and this side has length 2. This is our 60-degree angle. This is the angle we cut in half, so this one's 30 degrees, and this one's 90 degrees. And the same goes for this side. This is 1 and 2, and then the angles are the same. So now I want to find the sine, cosine, and tangent of 30 degrees and 60 degrees. So let me get another piece of paper out here. So let's see if I can do this. Okay. Alright, so I'm keeping the figure, or the picture here in place. So if I wanted to do the sine, we'll get the 30 degrees out of the way here. Sine of 30 degrees is going to be, so I need to look at this angle here. I need to do the side opposite, so 1 over 2. 1/2. So then cosine of 30 degrees, well, that's going to be adjacent, so it's square root of 3 over 2. Adjacent over hypotenuse. And tangent of 30 degrees is equal to opposite over adjacent, so it's 1 over the square root of 3, which if you had to rationalize the denominator would be square root of 3 over 3. Okay, so now we have to find the 60 degrees. So sine of 60 degrees, well, so I need to take a look at the 60 degree angle. Opposite over adjacent is square root of 3 over 2. Cosine of 60 degrees. Well, that's, if we look at the 60 degree angle, it's the adjacent over the hypotenuse, so it's 1/2. And then tangent of 60 degrees is equal to opposite over adjacent, so square root of 3 over 1, or square root of 3. Okay. Right. So you can also, besides these special angles, you can use 45 degrees, 30 degrees, and 60 degrees. You can use your calculators to find other angles. Okay. So now if I continue on, you might have noticed from this table here that so there's one thing I want you to notice about this table, or you may have noticed it already. Check out the sine of 30 degrees and the sine, or in the cosine of 60 degrees. They're both 1/2. Now, the cosine of 30 degrees and the sine of 60 degrees are both square root of 3 over 2. So, this gives us this leads us to those relationships and a couple other relationships. We can get, these are called co-function identities. So we get that the sine of theta is, you can write this as the cosine of, and this is in radians, so pi over 2 minus theta. So that's the radian version. So if I wanted to do this in degrees, you could do sine of theta is equal to cosine of 90 degrees minus theta, so degree. Okay, so for example, if theta, let's just set theta here equal to 30 degrees. So the sine of 30 degrees is equal to the cosine of 90 minus 30 degrees, cosine of 60 degrees. So the sine of 30 degrees, 1/2, is equal to the cosine of 60 degrees. So it's not just, it doesn't just happen for these two, for 30 degrees and 60 degrees. You can put any angle you want, any theta. You could put 42 degrees in here for theta. It doesn't matter. This holds true for all angles. Okay, so some other ones are, so cosine of theta is equal to the sine of theta, or of pi over 2 minus theta. So again, that's in radian. The tangent of theta is equal to the cotangent pi over 2 minus theta. The cotangent of theta is equal to the tangent of pi over 2 minus theta. And the secant of theta is equal to the cosecant of pi over 2 minus theta. And finally, we have the cosecant of theta is equal to the secant of theta. Secant of pi over 2 minus theta. So we have these following relationships. So these are all in radians. If you want degree, pi over 2 radians is 90 degrees. Okay. Okay, so let's do an example using these identities here. So we've got 2a, given that the cotangent of 68 degrees is approximately equal to 0.4040. Find the tangent of 22 degrees. So first off, you can note that 22 plus 68 So 22 plus 68 is equal to 90 degrees. 22 degrees plus 68 degrees is equal to 90 degrees. Okay, so this is going to help us because we know if we wanted to find the tangent of 22, so I'm going to look at my table here. So tangent of theta is equal to cotangent of pi over 2 minus theta. So the tangent of 22 degrees is equal to the cotangent of, so I'm not in radians, so I'm not going to do pi over 2. I'm going to do 90 degrees minus 22 degrees. So that's equal to the cotangent, conveniently, of 68 degrees, which we know to be 0.4040. So the tangent of 22 is about 0.4040. Okay, so so now they want us to find, the second one is find cosine of 72 degrees over the sine of 18 degrees. So they didn't even give us a given angle here. So the cosine of 72 degrees, I'm sorry, so first, yeah. Let's look at just the numerator here. So the cosine of 72 degrees. So if I look at the cosine of 72 degrees equals the sine of 90 degrees minus 72 degrees. So that's equal to the sine of 90 degrees minus 72 degrees, which is equal to the sine of 12 degrees. So cosine of 72 degrees is equal to the sine of I'm sorry, not 12. 90 minus 72 is 18. So I can substitute sine of 18 degrees in for cosine of 72. So this thing here is equal to sine of 18 degrees over the sine of 18 degrees. So it's the same number over the same number, so this is equal to 1. Alright, so that's how you can use those co-function identities to do those examples. Okay, so now at this point, I'm just going to do 2 application problems. So we usually don't do too many of these, but we're nearing the end of the lesson. So 2 more application problems and we will be done. So the first one is, let's say we have a cloud. So here's the ground. And we have a cloud up here. And we want to know the height of the cloud above the ground. Okay, so let's say that we are standing right here, which this distance is 150 feet away. So we're standing, so if you drew a straight line from the cloud down to the ground, we are standing 150 feet away from that point. And we notice that we're looking up at that point on the cloud, and we figured out that we got our protractor out, and we figured out that the angle of us looking up at the cloud is 68.2 degrees. So this angle is 68.2 degrees, and this is 150 feet long. So, and they want you to find the h. Okay, so this is a right triangle. Find h. So we're going to use our trigonometric rules. So this side here are our trig identities, or trig functions, to find h. So this side of the triangle here, this dotted line, is the hypotenuse because it's opposite the right triangle. Okay, so the idea behind this is, well, could I use sine, cosine, or tangent to figure out the height of this cloud? So if I were to use sine, I would get that the sine of 68.2 degrees is equal to, remember, sine is the opposite over the hypotenuse, so it's h over I'll just call this c, h over c. That's the length of this, unknown length of this side here. So I don't have enough to solve for h because I have 2 unknowns in this equation. You can put sine of 62.8 in your calculator and get a number for it. Okay, so sine is not correct. Or I won't say not correct, won't work. What about cosine? So cosine, okay, so the cosine of 68.2 degrees is equal to adjacent, which is, okay, 150 feet, divided by c. So this could work because if you solve for c, you could solve this for c, and then you could use the Pythagorean theorem to figure out what h is. So this would work. But also, if you wanted to do this just in one, solve for h in one calculation, the tangent is the best way to go. Because tangent involves your unknown side that you want to find and the side that you know. So it's h, the opposite, over the adjacent. Okay, so this works faster. But both of these methods will give you the correct answer. So if I just multiply both sides by 150 times the tangent of 68.2 degrees, that's going to be the height of your cloud. And it turns out that that's about 150 times the tangent of 62.8 is about 375 feet. Okay. So let's do one more example. Let's talk about, let's say we had a river. Somehow this river is extremely, it's got straight banks. So we're going to try and find the width of the river. Find W equal width. So if you wanted to swim across this river at this point, how far is that swim? Okay, well, you can't do this without any information, but I'm going to label this side W. So we're, from this point to this point, it's 200 feet. Okay, so then we also are given that the angle here is theta is equal to 58, not 50, 58 degrees. But my 8s are so bad. 58 degrees. Okay, so we want to find out what the width is. So I know, so I have this angle. Here's my hypotenuse, this dotted line. I don't know the length of the hypotenuse. I want to find the width, but I do know the length of the adjacent side. So again, the correct choice is tangent, because you know the adjacent side and you want to find the opposite. And tangent, or cotangent would work too. So if you did cotangent of 58 degrees is equal to, remember cotangent, if tangent is equal to opposite over adjacent, cotangent is adjacent over the opposite. So if I multiply both sides by W, you get W times cotangent of 58 degrees is equal to 200. So if I now divide both sides by cotangent of 58, you get that W is equal to 200 divided by the cotangent of 58 degrees. Okay, so if you want to do this with tangent, you would have that the tangent of 58 degrees is equal to W over 200. So this says that 200 times the tangent of 58 degrees is equal to W. So sorry that got a little messy there at the end. So these are two different ways to do it. So all in all, if you calculated 200 times the tangent of 58 or 200 divided by the cotangent of 58, your W, your width of the river, is about 320.07 feet. So I did these calculations on the calculator. These two are the same. Okay, so that's about all I've got for you today. So, well, just to know with these applications, you want to, when you're given an angle and you have to find a side, just identify adjacent, opposite, and hypotenuse, and then you can make your decision on what you need to use from there. All right, that's all I have for today. Thanks, and I'll put up another lecture tomorrow.